Okay, so this is the 5A practice worksheet. So it talks about the rational zero theorem. For those of you that weren't here last Friday, the rational zero theorem states that any quotient made by the constant term, so for example 12, and the leading coefficient, any quotient made by any of those factors is a possible rational zero of the function. So here's an example of that. So for example, factors of 12 include 1, 2, 3, 4, 6, and 12. And then factors of 1 is just 1. So for a second here, I'm going to label the factors of 12 as P, and then I'm going to label the factors of 1 as Q. So then any quotient of that, so any P over Q that I make with these factors could be a possible rational zero. So I always want to do the positive and the negative. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, 4 over 1, 6 over 1, and 12 over 1. So those are all my possible rational zeros for the function h of x. Okay, so let's look at number 3. So it says g of x is 5x cubed plus x squared minus x plus 8. So I'm going to look for factors of 8 first. So factors of 8 include 1, 2, 4, and 8. Factors of 5 include 1 and 5. Now, I want to make quotients out of these. So once again, this is my P, this is my Q. So I'm looking at what combinations can I make for P over Q. So plus or minus, I get 1 over 1, I get 1 over 5, I get 2 over 1, 2 over 5, 4 over 1, 4 over 5, 8 over 1, 8 over 5. I always want to make sure to see if I have any fractions that are the same. In this case, I don't have any fractions that are the same, so I don't need to cross off any. So these are all the possible rational zeros for the function g of x. Okay, so now we're going to actually find all these rational zeros. So not just all the possible ones, but which ones actually go into the functions. So let's take a look at number 5 first. So possible rational zeros. So let's start off with listing factors of 8. So factors of 8 include 1, 2, 4, and 8. And then factors of 1 is just 1. Okay, so this is my P, this is my Q. I want to find all the possible P over Q, so I'm going to just write them on the side here. So it's always going to be plus or minus. 1 over 1 is 1, 2 over 1 is 2, 4 over 1 is 4, and 8 over 1 is 8. Okay, so now we need to actually start plugging in each of these possible quotients to find which ones actually fit into the function. So what I always do is I always start by the small numbers first. So I want to start with positive 1. So I'm going to do synthetic division using positive 1. So I have 1. I'm going to write down the coefficients of this function. So I've got 1, 3, -6, and -8. Okay. So if I do synthetic division, the 1 comes down. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. Add those. -2. Okay, so I get -10. So my remainder is -10. So I know that this is not a, a solution to g of x. Okay, so now I'm going to move on. I'm going to choose -1 next. Remember, we have plus or minus each of these numbers. So if I try -1, so I get -1, and then I have 1, 3, -6, and -8. Okay, doing the same thing. So I get 1 times -1 is -1. Add those together. -1 times 2 is -2. -6 plus -2 is -8. -8 times -1 is +8. Okay, so here I get a remainder of 0. So this is a solution. This is what we're looking for. So now I can rewrite the original function. So I can rewrite the q of x function as, let's see, x plus 1 and x squared plus 2x minus 8. So I'm getting the x squared plus 2x minus 8 from the depressed polynomial I get from my synthetic division. Okay, so I can factor this even more. So I'm trying to think of what two numbers multiply to -8 and add up to +2. So that would be +4 and -2. So I get x plus 4 and x minus 2. Okay, so this tells me, so it's all factored now, this tells me that my zeros are at -1, -4, and +2. Remember, you want to do the opposite signs of what's inside the parentheses. And we started off, remember, with a cubic function, so it makes sense that we'd end up with 3 real zeros in the end. Okay, so last problem. So I'm going to go over number 10. So same idea as the previous one, we want to find all of the rational zeros for this function. So once again, I'm looking at the number 20. I'm trying to figure out what are factors of 20. So I'm going to figure out my p's. So factors of 20 include 1, 2, 4, 5, 10, and 20. And factors of q is just 1, because I've got 1x cubed. So I've got a 1. So my p over q possibilities are plus or minus all of my p values, because everything's over 1. So 1 over 1 would be 1, for example. 2 over 1 is 2. 4 over 1 is 4. 5 over 1 is 5. Okay. So remember, it's plus or minus each of these values. Now I'm going to start doing my synthetic division. I always start with the smaller numbers. So I'm going to start with 1. Okay, so I've got 1, 0, 6, and 20. Okay, this 1 comes down. 1 times 1 is 1. 7, 7, 27. Okay, so clearly this is not what we want. So I'm just going to put an x next to it. So we're going to move on. Let's do -1 next. So I've got -1. I'm setting up my synthetic division. Okay, so 1 times -1 is -1. Add those together. Got a 1, 7. 7 times -1 is -7. Add those together and I get 13. That is not what I want, so I'm going to put an x next to that too. Okay, so let's try 2 next. So +2 and same coefficients. Okay, so let's move this. So yeah, 1 times 2 is 2, 2, 4, 10, 20. Okay, so I get a remainder of 40, which is not what I want either. So I'm going to cross that out. Okay, so now let's try -2. So -2, 1, 0, 6, and 20. So the 1 comes down. 1 times -2 is -2. Add those together. -2 times -2 is 4. Add those. 10 times -2 is -20. Oh, this might look like it works. Okay, so we got a remainder of 0, which means this is a solution. So this is good. Um, so I can rewrite the original function, my x cubed plus 6x plus 20, in the form x plus 2 and x squared minus 2x plus 10. So remember, the x plus 2 comes from the minus 2 that I did my synthetic division with, and then the x squared minus 2x plus 10 is the depressed polynomial I get out of the synthetic division. So now I'm trying to think of what two numbers multiply to +10, add up to -2. Off the top of my head, I can't come up with any two numbers that would satisfy those requirements, so I'm going to use the quadratic formula. So I'm going to do the quadratic formula just for the second half of it. So x equals -b. Negative times negative is a positive, so I've got +2 plus or minus square root of b squared, so that would be -2 squared is +4, minus 4 times AC, so A is 1, and then C is 10, so I'm going to write 4 times 10 over 2A, so 2 times 1 is 2. Okay, I'm going to simplify this, so I got 2 plus or minus square root. So 4 minus 4 times 10 is 40. So 4 minus 40 is -36 over 2. Now I have a negative under the radical, which means that I have a imaginary root. So square root of 36 is 6. So I have plus or minus 6i all over 2, which means that I can divide the top and the bottom by 2. So I get 1 plus or minus 3i. So my possible roots for the cubic function b of x is, let's scroll down, okay, uh, x equals -2. Remember, so the -2 we get from the synthetic division that we did. It comes from right here. It's also shown right here as well. So my -2, and then the ones that I just found, so 1 plus 3i and 1 minus 3i. So this is my final answer. Okay, and that is it. The rest of the answers should be posted, so you can check your answers as well.